Hi, everyone, and welcome to a new episode of Cloud Native Live. I'm your host for this week, Taylor, and I just wanted to welcome you all. This is the stream where we get to go over basically the guts of all the different cloud native technology. You get to learn how everything works, get to see demos of how it's made, and it's a pretty exciting time. Now, this is a CNCF, so please remember that it is governed by the CNCF Code of Conduct, which basically boils down to please be respectful for each other. So in the comments and chat, which we hope there's lots of, please let us know if you have any questions, and please be respectful. So with that, let's go ahead and kick off. So today we have Yusuf and Nasir, and I'll let them go ahead and introduce themselves. So Yusuf, why don't you kick it off and introduce yourself?
Hey guys, good morning, good evening, good afternoon to all the viewers for CNCF. I am
Yusuf. In the comments and chat, which we hope there's. Looks like you might have had the live stream on another tab, Yusuf. So and introduce themselves. So Yusuf, why don't you kick it off and introduce yourself?
I'm not sure what's going on.
Go ahead, Nasir. Go ahead and introduce yourself real quick while Yusuf's figuring that out.
Yeah. Hey, so this is Nasir, and I'm a senior software engineer at StackGen. And it's been like 7 years of I have total experience, and I've been working with Docker, Kubernetes, and the cloud things, and a lot of writing applications in serverless, then writing application and that gets deployed in Kubernetes. And over here today, we are to talk about the challenges that we have faced and the experiences that we have so far accumulated. Like when should we use the one and the other one? And that's what we're gonna share with everyone.
Awesome. Yusuf, did you want to finish introducing yourself, or should we just kick right into the?
No, sorry. Yeah, you were actually right. I was viewing it somewhere else, and that's where it got messed up. Right. So, hey everyone. I'm Yusuf Kachwala. I am a software engineer at StackGen, and I'm excited to be here talking about how to move our serverless workloads to Kubernetes, why we want to do it, what are the scenarios that we want to cover, and then we'll be jumping right into a live demo, into the real meat of it. And Nasir here has graciously accepted to demo a live how to transition or how to move a live serverless function into Kubernetes. So, Nasir, why don't you share your screen and we take it from there? So today we are going to talk about moving our workloads, compute workloads from serverless to Kubernetes. We made our round of introduction. I am Yusuf Kachwala, and I've got Nasir Rabbani with me today. And what we are going to talk about is when to leverage a serverless architecture. What are the challenges you may face when you are working with serverless architectures? And we'll see a live demo, right? So let's talk about serverless. When serverless came, the serverless paradigm was introduced to us as developers, we thought all our problems are solved, right? No servers to manage, no infrastructure to manage, no infrastructure as code to write, just write your application source code, and then it gets deployed directly. You don't have to worry about your infrastructure at all, right? No service to manage. And it is true, but there are it requires the serverless, you use serverless architectures in specific scenarios and specific situations. One of the use cases where you may want to use serverless is when you have an event-driven architecture. So serverless shines when you're operating with event-driven architectures. For example, you want to react to events such as file uploads. You want to react to HTTP requests, database changes. Maybe think of you can also use the serverless architecture as a cron job kind of system where you can basically take automated backups, schedule some tasks, and so on and so forth. Another place when you would want to really use serverless architectures is when your functions are short-lived. So basically, you are just doing small, lightweight tasks such as image resizing or maybe data transformations. You're taking data from one source, transforming it, and pushing it to another source. Or maybe you are sending notifications. You're maybe doing reacting to events and sending to, email notifications, or there are different types of notifications that you can send. Another place where serverless really helps is when you have sporadic traffic, unpredictable traffic. So serverless helps you scale on demand. It scales up, scales down. In fact, scales down to zero when you don't need the function running at all, right? So when you have unpredictable traffic, you expect not a lot of traffic to come, but sporadic traffic. So that's the point. That is one of the use cases where you can use serverless really well. Another place you can use serverless really well is for proof of concepts, right? So you have a project, you have a hobby project, you want to see how it works, you want to get it deployed without getting into the complex architectures of different cloud vendors, and spinning up managed services and whatnot, right? This is where serverless really comes in really handy. You just focus on your code, on your application code, and just go ahead with it, right? And there are a lot of other reasons and a lot of other use cases where you can use serverless. These are just the few that we are discussing, right? And then I would like to mention when not to use serverless. Okay, so probably when you have long-running processes. For example, there is a process which is going to take a lot of amount of time to execute and finish. Probably then serverless is not the best choice of architecture over here, or not the best framework to use. Similarly, if you have got lots of complex workflows, for example, the output of one serverless function serves as an input in some other function, and then the output of that serves as an input to third, and then you've got complex workflows going on with state management coming in picture, and probably that's the place where you may not want to use serverless as one of the architectures. Another point where you may not want to use serverless is when you want high performance computing and you want real throughput on CPU and memory, and probably serverless doesn't really work there. So we talked about right now when to use serverless and when not to use serverless. And let's talk about the challenges that you face using serverless architectures and how transitioning from serverless to Kubernetes may help, right? So for example, you started off your application as an event-based architecture, but now as you move ahead and your application evolves, probably it's not an event-driven architecture anymore. And that's the point you consider to move away from serverless into Kubernetes. As you keep on developing your application, as with rapid development and GitHub Copilots coming in, and lots of AI, artificial intelligence coming in, and developer productivity going through the roof, right? Increased code size is one of the places where you may run out of. You may consider that serverless is not the best way because it has a limit on the code size that the function can use, right? So probably you've increased your code size and you may not want to use serverless anymore. Increased code size also has a repercussion of cold start. So cold start is a very, very prominent problem in serverless. If you have your serverless function sitting idle for a very long amount of time, it gets killed by the platform on which you're running. And then when you get a request, the function takes time to boot up because it will first download the source code. It will boot up. If there is a compiler dependency or there is a JVM kind of dependency, it downloads everything and then boots up your code. And then cold starts become real problem for latency sensitive applications. And that's the point where you may feel that, okay, you know what, serverless, I have to rethink my serverless approach. Limited execution time is a problem where we just discussed that it's not for long running processes. So if you have reached to a point where your service or your functions are running for a long amount of time, then you may not want to use serverless and you may move to Kubernetes. We discussed about complex workflows, output of one function into another, then another to a third, and then third to fourth, and this whole complex workflows going on with state management and stuff like that. And we may find that serverless is not not really the most ideal situation, most ideal framework to use. Vendor lock-in. So if you're using cloud specific functions, or cloud vendor specific serverless platforms, then you may get locked into the vendor. And probably Kubernetes is one of the best ways to make yourself vendor agnostic. Like, okay, you can take your application and deploy it on Kubernetes, and Kubernetes can run anywhere. It can run in your hosted environment, it can run in any cloud, and it just decouples you from cloud. Scalability issues, right? So one of the reasons you may want to move away from serverless to Kubernetes is scalability. So the scalability that you achieve in serverless is if you have a serverless function which is running and it takes X amount of time to execute, and within that time, if you are hit with another 5 or 7 requests, it will spin up new functions to basically address the increased demand. And this is the point where you may see increased costs, because as you know that you pay as you use, and if you're using more serverless functions, then you may pay more. And that's the point where Kubernetes can bring or help you with manage your scalability. It can take care of the number of replicas that are running, or you can use many open source tools, which is really a benchmark of Kubernetes. Like, there are so many tools that help you scale up and down. There is Scala, there is Carpenter, and lots of other tools which help you manage your scaling aspects. And one of the last points which I can think of is, if you want the control of your own infrastructure, serverless, someone else is managing the infrastructure, and you really want to take charge of your own infrastructure. And probably that's the point where you can think of moving to Kubernetes, because you manage your own infrastructure over there. So we started off with discussing when to use serverless, when not to use serverless, and why we may want to move from serverless to Kubernetes, and how Kubernetes may solve a few of these problems that are listed on this particular slide. So with that, I've done a lot of speaking. I'll let Nasser dive right into the demo, and we'll see how to migrate a real serverless function into Kubernetes. Take away, Nasser.
Thanks, Joseph. That was very helpful information that you shared. And so let's see, like the actual transition that we'll be doing over here. So let me clean up my messed up screen. Okay, so I have slide over slide. Sorry about that. So I just wanted to show a pictorial view of the cold start problem that we discussed, which is a really big problem that people are talking about. Like, why cold start? What exactly is cold start? So the paradigm that the serverless take is, you only pay when you're using is good, because we are not running something that we're not using. But at the same time, when you want to use it, what it does is, like, it starts from the beginning. So what it does is, it will take the code, create the containers, start it, and then it's available to serve your request. It has to do a lot of steps before it can serve your request, right? So the steps it does before serving our request is what is generally referred as the cold start. And then when it is up and you are making subsequent requests very close to each other, then it's already there. The environment is up and can take the multiple requests. But again, when you have to take parallel requests at the same time, then the problem again occurs. So what's going to happen is, if one function is serving one request and the other comes, it's going to go and spin up a new instance of that particular function. And that's where the cold start will happen again, right? So just wanted to add a little bit more detail on that. So now let's talk about the migration part from the functions to actual self-contained complete application. So I have a few source code that I would be showing to just to like differentiate between the changes, to identify the change that we might have to go through. So before we do that, I would say that yeah, it is. It doesn't. It's not very straightforward. It is straightforward, not very complex, but still, it takes a little bit of changes that we can make it a Kubernetes ready. So I hope my fonts are visible.
Yes, maybe you can zoom in a little.
Okay. Oh, sorry. Did I mess up? Okay, I think I have messed up my controls. Okay,
It's fine. We can view it. Don't worry about it.
okay. I'll be slow in scrolling. So this is actually a serverless function that we have, and it's from a specific vendor, and hence it has a specific way of writing the function, and this will vary from vendor to vendor. So everyone has their own way of writing the function. The function signature you have to match, and then you write the logic under it, right? But this will become a problem if you want to change the vendor. Is again you have to make the changes. So the solution could be is like, once you are making the change, let's make it in a way that we are no more locked to a specific vendor or a specific platform or something. So yeah, this is what it looks like. You're gonna have a function. You just define the signature, and then you write the logic, and that's pretty much it. This is a Go example. This would change from language to language. Python would have a different implementation of it, but something similar. The concept is same, that you have to like implement a specific function signature, and then everything takes cared by the serverless platform that you're using. Now, if I have to look at the source code of the KRS, like Kubernetes. So we have that code, and let's see. We still have that handler function, but the signature could be different based on the framework that we're using. Right now, I'm using a Gin framework for Go, so it has a specific way of writing the handlers. If you use the basic net HTTP package, it's going to have a different signature over there. But the difference that we will have is how we are exactly going to call that particular handler, right? So let me discuss point by point. We'll come to the code and discuss a little bit more of it. So the initial setup that we would need, the tools that we would need for this particular demo to run, or maybe if you're trying to do hands-on something on your own. So right now I'm using Kind. Kind is basically Kubernetes in Docker. So we have Docker in our machine that we can run cluster or Kubernetes flavor in our own Docker in our local machine. Then Docker, I'll talk a little bit more than just Docker. It is a containerization technique. So this is the gist of it. Like the main thing that makes everything Kubernetes friendly is the containers. So what exactly are containers? Containers are basically a self-contained environment. So in case of functions, we just write the function, that's it. We don't have to do anything. But when we migrate to Kubernetes, we have to do a little bit of effort. First, we have to containerize our application. So what that means is we will have an environment which will have its own operating system, all the dependencies your application is going to need, the runtime it might need, and everything packaged together, which is like ready to be shipped in any sort of deployment where like containers are supported. Kubernetes is one of them, right? So Docker is just one tool to do that containerization. There are other tools available, but yeah, Docker is mostly used. And then there's a tool that we'll be using. kubectl is a command line tool that helps us interact with our Kubernetes clusters. And then K9 is an option, is just a tool which gives you a better view and better way of interacting with the cluster. It has a very intuitive design and commands and shortcuts. It's very helpful for the newbies who are just catching up with Kubernetes. And then Go is for me because subjective. If you're using Python, you might need Python in your machine to be able to verify and test. So now let's go back to the code and see what's going to change. The first thing is the change of the endpoint. In case
So
of,
uh,
yeah,
we are trying to basically change the function which is running in the serverless platform to something which may run into Kubernetes, right? So that's the source code change that we are trying to do over here,
correct.
making it.
So the application is going to be same. It's just the way we are writing that application changes. The paradigm changes a little bit. Because in case of serverless, we do not have to manage the entry points, right? We just write the function, and whatever the platform you're using for functions, serverless function, they manage the interaction with. Like, how do you interact with that function? They take care of that. But over here, we're gonna have to do it ourselves.
So
And I'll
before you
show.
move ahead with the code change, before you move ahead with the code change, do you have like a demo of this particular function running on serverless?
Yes, so I have it deployed already. So I can just simply maybe hop onto my Postman, and then try to do a quick call. So this function is basically doing, so it takes a sentence or multiple sentences, counts the how many sentences, the how many words and how many letters there. And let me call this function. Yeah. So it was able to count like, okay, it has 11 words, 67 characters, and two sentences. So basic, very simple application, does nothing much, just to show the usability of this thing. So it is coming from a source is serverless, so it's a serverless function that is deployed. So yeah, we will have the
Awesome.
same function working in our own clusters.
Awesome. And we are going to take this function and then
Correct.
migrate to Kubernetes now.
Correct. So the original function that we showed over here is going to be the same. The business logic is going to be the same. It's just the like the way we are writing it, the signatures of the functions, and things going to change. I'm going to compare while I'm showing the change. So yeah. So we still have our structs or anything that we are using to do the data transfers. We still have the function, just the signature is changed over here. And then we'll have our similar business logic. So the signature actually defines how you are accepting the arguments into that particular function. So over there in serverless, they will have some sort of event because it's mostly event-driven system, and in the event you get the payload and everything. But in case of Jane, it has a separate way of handling it. Then you have to do a JSON bind to bind it with a struct or any object that you might be using to do the data manipulations. And then the basic difference is here. So in case of serverless, it was just the function call itself. But over here, we're going to have to actually write a server and define some endpoint and then bind that endpoint with that handler. So what's going to happen is this application is no more just a function. It's a full-fledged application which can run on a port and take incoming connections on a specific port, map to a route, and then pass on your control to the handler where the business logic is going to happen. And then the same route is going to give and return your response.
So why do we need to create a server here? Like, what's the why do we need a server here? Like, what's the use case?
Yeah. So to be able to interact with this application, now that we do not have any like framework or any application that is managing our functions, we have to do it ourselves now. So this is how you will be interacting with the system. Does that
Got
answer
it.
your question, or you're expecting something else?
No, no. I mean, it makes sense. So what I'm trying to understand is when we are moving away from serverless into Kubernetes, we're trying to make our service run so that
Mhm.
it is access, and then we are adding an HTTP server so that we can expose the endpoint for the external world to access it.
Correct. So, so yeah, this is the basic change. The first and most important change that we're going to have to make is expose an endpoint to be able to interact with the function. Now that we do not have a platform doing it for us. So yeah, I'll try to move ahead. So we will have to choose some sort of web server or framework. For in my case, it was Jane. It could be Flask or something in case of Python, and then like every language has their own. No, so my application do not actually need this particular application needs any environment variable that doesn't depend upon it. But in real life application, it does. We do secrets management sometimes or some specific configuration that comes from the environment. So that changes a little bit. Now this environment variable management is going to happen. It's something that Kubernetes provides called as the config map. So we can put some values, and this can go in. We can customize it for every environment, your production, your staging, maybe dev or something, QA environment stuff, and we can have specific values for those configurations, which we can specify in this config map for each environment, and it's going to behave and it's going to read those config from there. And then updating logging and monitoring system we're going to have to do. So when we are working with functions, serverless functions, we generally do it with some sort of vendor, and those vendors have their own monitoring and logging mechanism, and we are bound to use those because they are just the way they are tied. We do not have much control that okay, for this particular function I'm going to do entire like setup of everything, and it's really hard to even if you do it, it's really hard to access those logs or those matrices and then share it with something other tool and then visualizes. But over here we have the full control. We can use like open source things like Prometheus, and we can use Grafana or something. Then we can put our logs or have some metrics monitoring, and we can have dashboards and everything that on our will, whatever we want, the way we want it. Cool. So okay, moving forward. Now here are the fun stuff that's gonna happen. So these are a little bit of overhead that we're gonna have to do to have the fun. So I explained what a Docker is and how containerization happen, but this is where we're gonna look at what happens. So I have this application. In case of serverless, you would just go and deploy that function, maybe just make it a zip file and do it. And there are some platforms that support containers as well. So few people might have done that, but I would just take a little time to explain it. So over here in Kubernetes, when we are going to deploy it, we cannot just take the code into it. So we're going to have to containerize it. And for that, we need some sort of configuration and some instruction that how should I package this and how should I create the image out of it. So we will have to include a Docker file. Okay. So this is the configuration that Docker would use to package or create an image out of your application. So this is a multi-stage Docker file. So what's happening is, as I said, a container is a complete system. It will have an operating system. So this is our base operating system that where our application is gonna run. So this app already has the Golang. It's specific for Golang, so this operating system will have Golang installed in it. And then we define the working directory, in which directory we're going to do the work. And then we copy our code, the piece of file that we need inside that container. Then we're going to resolve the dependencies. And then we are just copy pasting the code, and then we are building the code. So Go is actually a compiled language, so it's going to convert into a binary over here. So the benefit of doing a multi-stage is, in the first stage, which is the builder stage, we do a lot of stuff, right? We copy a bunch of files that are required, then we copy dependencies, then we might have some sort of extra plugins that we might need to build our code. But once the binary is ready, we do not need anything, right? So what we can do in the next stage is we can discard everything that we had, just take that particular binary which is going to run, and then package our image. So by that way, we are optimizing our Docker images, the container images, and make it small sized, right? So it's easy to like download for the services and everything. Now we are going to have the Alpine latest, because now that binary is already built, we do not need Golang, right? So we can just have Alpine. This is the one of the slimmest operating system that is available. Then our work directory is this. From the builder stage, which is the top one, we are copying just the binary name. In that case, it was main, because that's what I named it, and putting inside bin directory. And this application is going to run on 8083 port. So we are exposing that port so that we can communicate with it. And then the command is going to run when we execute this particular image. So are we good?
Yep.
Awesome. So that part was how we can package our application, make it ready for the deployment, right? So we are mostly done from our like dev part of it, like building the application, modifying the application, making the image. Now taking it to deployment, right? So for that, Kubernetes also needs some sort of configurations or some instruction that, okay, what should I do? How should I do it? How do you want to manage it, right? For that, we have a YAML file that Kubernetes takes, and for now we're calling it manifest file. So let's see what we have here. Okay,
So
so
Nasir, is it like a standard format that Kubernetes accepts, or
yes,
okay?
so this is a specific format that we have to write it. So there's a specifications as well, that okay, what are the fields that you can mention, and then what is this kind? Because if you notice over here, the kinds are two different things. One says deployment, one says service, right? And
So
then you have different arguments as well. Yeah, go ahead.
So when we are migrating our serverless applications to Kubernetes, writing this manifest file is something we'll have to know, like we'll have to understand. We have to, there's a
Yeah,
learning curve.
that is yeah. That's so. This will takes a little bit of learning curve to learn writing this particular configuration, right? So yeah, I wish it was auto generated, but right now I did the
Well,
part to write it.
I have a related question there, Nasir. So, obviously, probably a lot of people on who are listening to the stream or watch it after are at least decently familiar with Kubernetes, right? And if you, we've gotten several questions actually in the chat that I think kind of tie into this. Of um, there, one person asked that basically like every hyperscaler runtime has a different like has their own like version of Kubernetes that have all the services that are um, that are on there, and then you have this idea of like migration costs versus lock-in costs. So this would be like on that migration cost side. So I'm curious, especially just like, and just me personally as well, like having done both of these things quite a bit. What was the motivation that would make somebody want to come over? I mean, you talk some of the things about the serverless, but like when does that what can people kind of take for their kind of cost benefit analysis as they come and they look at this and say, okay, well, I'm going to have to create Kubernetes manifests, um, and so like is and then you have to define how you're going to manage those manifests, how you're going to deploy them, all of those types of things, which I think is the bigger amount of effort. Like what kind of things should people look at when they're considering doing something like this?
Absolutely. So when you're migrating or when you're thinking of migrating from serverless to Kubernetes, right? So you have to evaluate whether the migration cost is worth the cost of vendor lock-in or your existing cost, right? So migration costs basically come with a lot of overheads. For example, you have to write your manifest, you have to make source code changes, you have to create a Docker file, basically containerize your applications. You have to maintain your manifest files, make sure that the prod deployments, then you'll have different environments like stage, prod, dev, and whatnot, right? And then basically you'll have to maintain those through GitOps model, make sure that you have some integrations to push your changes out into prod every time you have a change. So maybe some open source tool or maybe an Argo CD kind of a tool which basically monitors your manifests every time they get updated. So there is some considerable cost that that is involved when you're migrating a serverless to Kubernetes, right? And you have to basically take that call for your own self, like how important it is, how acute your problem is with serverless, and then making that migration makes sense or not. So we do have a slide at the end after this demo to just to cater to some of these questions, like what the migration strategies should be, what to migrate, when to migrate, and so on and so forth. But yeah, I agree that there is a migration cost involved. There may be a learning curve for the team, because if they're not aware of Kubernetes, or they're not aware of how to manage the IACs that are generated, then I mean, there is some cost. So you have to choose your own poison, what you want to do. Are your vendor, is your vendor lock-in too tight? Or for example, you are on one vendor and then you've got a huge partnership with another vendor, right? And then probably you want to move all your serverless applications. So probably moving to Kubernetes makes sense, because then you can deploy those applications into other cloud environments or other vendors very easily without having a very strict lock-in into the cloud vendor, right? So you have to choose and be very subjective. This is a very subjective because there is no right answer here. We are just showing how to transition, but you have to make your call for your own self based on your use cases.
And I just want to call out one thing is the point we are trying to make is not that serverless is bad. It is good, right? It's just that it's not good for every solution. That is the whole point. So if you have built something, it works good, no need to migrate. But if you build something and now it has grown big, it has become complex, it's creating a pain point, then this could be a solution. So we are not saying that do not use serverless. Use serverless wisely. You don't have to fit in everything. Now that you started using serverless, now that you don't have to fit everything in them, right? So this is like thinking beyond that. So if you are not fitting it, you don't have to. Maybe there's a learning curve, but that we have an added benefit to it. Certainly not taking the pain for nothing.
I think that's a great answer. I think it's good to know, like, pick your right tool for the right thing. So that's great. I'll let you continue back on that. There is another question, but I think it's good. You mentioned that you have another slide at the end, kind of comparing, and I think it goes along with that probably a little bit better. So when we get there, those who did ask that question, we'll get to that as soon as we get towards the end there, because I think it'll fit in real great. So yeah, thanks for answering that.
Thank you.
So I would have these templates or whatever example that I'm showing up on my GitHub, and it's going to be open. People can take a look. I'm not going to spend a lot of time here, so I'm just going to explain quickly what these configuration looks like and what they do. So the first configuration says deployment, right? And then it is tied with some image of your application that's going to deploy. And then there is something called a service, which will act more like a load balancer. And then the way the Kubernetes work is it's a mesh, it's a cluster. So you have multiple application running, and each application can have multiple instances, so that it can give you. That's how we do high availability and then scalings and everything. And so there could be a question like, okay, what is the service then? So what it does? So service is like a layer sitting between your like the traffic and your actual deployment. So service will have multiple pods, multiple instance of the application running, and when you're trying to interact with some of the APIs or any of the service, you wouldn't know which pod or which instance you're trying to reach. So that's where the service is going to take care for you. So if one instance dies, Kubernetes is going to spin up another one based on the configuration. What we do is like how many you want active. And in the meanwhile, this service is going to take care of your routing of the traffic. That, okay, this is dead, so I'm going to route all the traffic to particular this instance, right? So I'll quickly move forward. So this is basically that, and then you have some resource management that you can do over here. That, okay, this is the limit of my memory and the CPU limits and everything, so that you do not kill your infrastructure just by one application going something wrong, right? So you can have control over that as well. So basically, this is the configuration. So I do see one comment that writing YAML is not difficult or complex. It is not, but what should you put the value is something that we need to be very mindful of. I mean, I can write this YAML and put some random values, but we don't want to do that, right? So definitely YAML is very simple, but yeah.
Yeah, YAML is simple, but it is what you make it. And any of us who've
Exactly.
played with it in Kubernetes enough knows that it can become quite complex, almost like its own programming language. So yeah, no,
Totally
you.
agree.
And mix a team collaboration on top of it. So like there are two people trying to edit the same YAML in a collaborative environment, and then you don't know what the output comes.
Absolutely. So let's see the magic there. So we have the Docker file, we have the Kubernetes configuration done. Now we will actually try to package that. So we have the code change done, Docker done, and then Kubernetes configuration done. Let's see the action. So there are a few commands that I have over here. Is for first one, Docker build. This command is gonna package and create an image out of a container image out of my code. Then we'll be pushing it to a registry from where there's Kubernetes can pull that image and use it for the deployment. So I'll just explain one thing and keep doing it at the same time. What poison I should choose using the same terminal? Probably, yeah. Okay. So Docker build, as the name says, is gonna build, and then we specify the name of the image. This dot basically gives you the path of this configuration, that is the Docker file. So if you name it, you don't need to, the dot is gonna pick it. But if you choose a custom name, then you're gonna have to specify where is your configuration for the Docker. So some of this might run a little bit faster on my machine because I have them like multiple layers are available. So it could take a little bit more time when you try to do it. But yeah, awesome. So I have the image created by this name. I can do Docker images, and it's gonna give me So I'm gonna do grep because might have a lot of them. Yeah. So yeah, actual the code I haven't changed since last 26 hours, so it's gonna still be the same. So yeah, I have this images, multiple instances I created, but this is the latest that I have, and so now we have the package created. It's in our machine. But one thing I want to explain over here is when we say about Kubernetes or even the container itself, as I already explained, it's a complete system. So it has everything's own. So local host inside the container is different than the local host in my machine. So it's the entire network. Same thing happens in Kubernetes. Kubernetes manages everything. It's the entire world of itself. So when you have something in your machine and you say that, okay, I can just use that same image, it's not going to work because this image should be accessible from the inside network of that Kubernetes. It should be able to pull it. So the easiest way right now I'm choosing is just push it to my Docker Hub. I have made it public, it's open, and I don't need any authentication for the simplicity of it. But if you have private registries, we need to give it access. So Docker login has to happen, or whatever registry that you have to give the credentials and access to that cluster. So I'm just gonna go with pushing the thing, image to my registry. It's gonna be quick because I already have one. There you go. Now coming to the Kubernetes part of it. So code done, packaging done, we have the image ready. Now let's move ahead. Kind, I already explained. This is sorry, what happened? Did I go? Okay, I went to editing mode. Okay, kind is Kubernetes in Docker. So something the flavor of Kubernetes that I have in my machine running. So let's understand how the umbrella, the architecture is gonna be. So we'll have something called as a cluster, which is a mesh. We have a lot of things running there, and then you could choose to have your entire application in one mesh. You can have multiple. Ideally, we don't, but we manage one cluster, and our applications are there. They interact with each other internally, and then we have some sort of uh, like configuration so that we can access it from the outside world. I'll talk about this configuration, that how we can access it from outside the world. And yeah, so kind create cluster, and then you assign a name. So this is the command for specific to kind to create a new cluster. I already have one. I'm not going to run this command again, but yeah, this is what we need to run to spawn a new cluster. Once the cluster is done, we're going to deploy our application into that particular cluster. So I need to be into that context. So few of the things that I'm talking is something that you're gonna like experience when you try to do it. I'm not going to like explain each and everything because we have limited time as well. So kubectl, the tool that we talked about, which lets us interact with the Kubernetes itself, kubectl is gonna apply my manifest configuration, right? The configuration file that we discussed, that we saw. Okay, fingers crossed. Sometimes like demos don't work perfectly, but see. Good. So it took two jobs, creating the deployment and creating the service. Now I can use like kubectl command itself to like verify my deployment is happening, my services, my pods and everything. But I want to take my time and try to see this K9s. So this is the tool that I talked about. It gives a little bit of better interactivity. I don't know if like it's visible or something. Yeah, I think it should be visible. So you press colon and then you do deployed auto suggest the commands as well. Very good for the new people trying out. So this is the deployment that we did. Text analyzer go. If you click on it, so this is the pod. Pod is the actual instance. So I've configured to run one instance of my application. So we have one. And as soon as okay, I'll play with that once I try to access that repository as well, endpoint as well. But once you kill it, Kubernetes is going to respawn quickly the other one, so that you always have one pod running. So your application is available. Okay, and then you can do service. This is the service that we ran right now. This is the load balancer that we have. Is going to make sure that we have one pod, so all the traffic is going to go to that one. But if you have multiple, it's going to like balance between them. So now that we have everything, we have the pod running, service up, deployment is ready. if we try to directly access it on our port, remember the 80831 is not gonna let us do that because this localhost 8083 my machine, not the cluster. So
Why
what are we
don't we
gonna have
try?
to do?
Why don't we try that once? Why don't we try accessing at 8083 and see the error response?
Okay, so I'm gonna do a ping. Okay, maybe you just want to call the API itself.
Yeah.
Okay, so I have this thing jotted down over here. So the simplicity. So if I try to hit it, connection refused because in my machine right now at 8083 nothing is happening. 8083 is happening, but inside the cluster in its own network, right? So what we need to do over here is there's a concept called as port forwarding. So 8083 of my machine is gonna hooked up with the 8083 port. I mean, you can give different port as well, but I have kept the same. So for the simplicity, it's gonna hook up to this 8083 port on the cluster inside it, right? So once I do that, so it's gonna say that okay, forwarding the port from here to this port. Now we are able to go inside that cluster and access the resources. Awesome. So it's coming from our cluster and it's giving the word count and everything. I don't know what I have. Let's say, yeah, it works. Same output, same business logic, just the paradigm has changed, the deployment environment has changed, and we have our control, what we want to do and how we want to do. We can like, if you want to just play around, you can go inside it, see the pod, and K9 has helps you with the command. So they have a bunch of shortcuts, like you can just press L for logs, and it's gonna show you, okay, these are the logs of my application over here. Definitely, we don't want to do that. We might have, in real case, some sort of logging mechanism, like so we can stream our log somewhere else, and then we can filter out everything. This is not gonna help tailing logs, but yeah, one way to look at it. So one thing that I wanted to show was if I do pod and you say this, I'm gonna delete it. Okay. See what's happening. Container creating. It instantly picked up and respawned a new one. So if anything crashed, some runtime exception came and something happened, which we should be as a developer be very cautious of, but certain thing happened, it's gonna still keep spawning a new one so that your service is always available. All right. So yeah, we tested the API, and maybe if we have some question at this time, should we?
I think there are a couple of questions there. Uh, so
Yeah.
one question is, when using services like AWS Fargate, do we still need to be concerned with the points you mentioned in why not serverless? Yeah, yeah. Uh, Probably I'll take this one after we've finished the demo, because I'll go back to the slides and we'll discuss a few things about the migration strategy, and I'll take this one back then. Any other question, Taylor, that is relevant to this particular section?
We don't have any more from the audience right now. I think this is a great demo of how this stuff works and straightforward. So let's go ahead and just have you finish it up, because I think you'll show how it all works here at the when everything's done. I I don't want to interrupt before you get to the final part here. So go right ahead.
I just want to take a few moments for the people who are really in love with, serverless. They want to have the experience of Kubernetes, but don't want to go away from the functional coding thing. So we do have some alternatives. So one of them is Knative, then OpenFast is there. So what these does is they are serverless alternatives, but they run on your Kubernetes. So you still have a function, you still write the function, but it will again have a different syntax of writing the function. The signature would be different, specific to any of this application, but you're still writing a function. Some of these will already make some mechanism to containerize it that you don't have to do it, and then you can deploy, and it's going to actually run on Kubernetes. So maybe if you are a little bit confused, should I actually move to Kubernetes or should I still be there? Maybe this is the mid thing. You can give it a try and see you like it. Maybe then take a decision if I should completely move to native Kubernetes eventually. Could be a good option for a POC or something. Now I have a small thing written over here. I think this could answer one of the question is we still have the overhead of writing those configurations, and then maybe in our real life example, like in a production grade application, we're not just writing our application. Our application or the function is talking to other resources. Like from if I am at a vendor, they might have some managed services, for example, some databases, maybe some storage, right? We do access those and use it. So when we're coming over here, we have to manage those everything, and then we should be thinking about the portability as well, because tomorrow I might have multiple instances. I might have different accounts of those vendors to deploy our things. So we want the portability. So that is so I see as a concept called as infrastructure code. I'm pretty sure people are familiar. I'm still taking a time to explain it. So we write some code that can provision our infrastructure, right? And we call them as IAC, infrastructure as code. And Terraform is like Open Tofu is there, and things are there. Like people are aware, people have been using it. But there's a new concept that's there in the market, and people have started talking about it. It's called IFC, infrastructure as code. A lot of things still yet to happen to it, but this is something a new paradigm. You write your application code and somehow figure out what uh, services you are using, what application is doing. Based out of that, create your infrastructure, and then you can take it for your deployment. So yeah, we should be like looking forward to it, the development that happens, like maybe multiple open source tools that is going to come up. So yeah, I think I'm done from my side.
Awesome. Thank you, Nasser. I think that was really helpful, very super clean demo. Thank you so much. Uh, Taylor, now at this point of time, I'll take a few moments to talk about some migration strategies that we want to implement while we are considering moving away from serverless to Kubernetes, right? So
And before, just to make sure I got it, so is this going to answer the question that I pulled back up on screen that we talked about earlier? Is like, so like, when do we not need to be concerned with the points about that? Is that kind of covering some of this answer?
not really, but let me start with answering this question first, and probably then I'll go to this slide. So this is a very valid point, right? So AWS Fargate does allow you to deploy containers, right? But then the same cloud vendor is offering you Kubernetes flavors as well. So it's not that the AWS Fargate is basically the solution to all your problems. But to take this particular use case that is asked, right? So this particular service, managed service, takes charges you based on CPU and memory allocation, right? And which can become very expensive if you suddenly scale your application to a huge amount. And that's where Kubernetes helps you. It manages. You can set the maximum replica. And the number of nodes on the cluster actually dictate the costs, right? So probably at the application level you can throttle your requests and whatnot, but from the cost point of view, there is a caveat that you cannot control the scaling factor over there. Similarly, you for managing the logs and everything, you'll have to still lock yourself into the vendor and make use of the vendor's logging mechanisms and monitoring mechanisms to take basically use them for your logging and monitoring. Another point is, even though this is a containerized application which you can use inside this particular managed service, you may still run into cold start issues. So even if your service is idle for some amount of time, pulling the Docker container or the container image and booting it up and then running, you may still run into cold start issues. And most important is you don't get state management. It was not designed for state management. In fact, the service was not introduced into serverless earlier. Now it's basically with evolving landscape, it's introduced here. So it basically doesn't. It's not designed to be stateful. So you still have to use a database, some blob storage, and everything to manage states. So if you're running in an application where a state management is important, then it may still be relevant to move away from this. I hope I've been able to answer that question. But again, as I said earlier in one of the slides, it's important to make sure that your use cases align with what you're trying to do. And this is where I want to talk about the migration strategy, that not all serverless functions need to migrate. Uh, you've identified in your organization that, okay, you're running into some issues with serverless, but moving all the for serverless functions into Kubernetes may not be the right answer. You have to identify, choose which ones are the real functions that you want to move into Kubernetes. Some may really be still event driven, maybe short lived, maybe still useful and relevant with the serverless use case. For complex workflows, right? So we discussed a little bit about complex workflows. So if there are functions, the output of one is consumed by another, and then there is a chain of data cascading going on between the functions, probably you can choose to combine them together and make them into a single service. That's where basically you will have an advantage of containerizing your application so that you minimize on that data cascade cost and avoid an external state management where you're pushing the data to a blob storage or some other mechanism. Maybe you're queuing it up or you're pushing it to database. That's the problem. That's the point where you may see some optimizations, as you may moving to Kubernetes, combining them together and moving to Kubernetes may help. This is so the application which Nasser showed was a very simple one. And in real world use cases, it may be very, very complicated. It may become difficult to migrate, or the source code changes may be quite comprehensive. So you have to make sure that you Dockerize your applications correctly. You manage your secrets well. You manage your environment variables well. You may be accessing databases from serverless, and then you move to Kubernetes. That may change. You may be accessing certain secrets. Kubernetes brings to you its own secret management through secrets, but you may still be locked into your vendors. You have to make those cautious calculations before you really think of migrating, right? And this was the point number 3. Nasser actually elaborated on it. Like you have fast function as a service platforms based on top of Kubernetes, and probably if your existing functions don't require a huge refactor, you can actually consider using these fast platforms as a point of doing proof of concepts, so that you know that Kubernetes is the right way to go. So I think that's it from my side as well. I hope today's session was helpful. We learned a little something out of it, and it may have benefited a few.
Awesome. Thank you so much. This was a really great explanation of and an interesting migration pattern. I don't think we've, at least while I've been hosting, we haven't really had a chat about. So this is really good to see. There's been some great conversation and chat, but we are at time. So please feel free to reach out. Is there any calls to action or places where people could maybe reach you or continue this discussion around the different trade-offs between the two?
Right, absolutely. Yeah, I mean, you can reach out to us at the given email, and yeah, feel free to contact us anytime. We would be happy to share our journey, our thoughts of what migration journey you can use, or what paths you can take, and also how infrastructure from code can benefit your use cases or your organizations.
Awesome. Well, thank you so much for coming and presenting this today. Thanks everyone for attending, and we will